Hello, everyone. Let's talk about the rules and properties of exponents today, right? But before we jump into some problems, I want to walk you through not only the properties of the exponents, but how to always get them correct. Okay, so let's start out with some simple examples. Okay, so suppose I want to multiply two exponential terms together, 2 to the third times 2 to the fifth. Okay, so what do? Do I multiply those exponents together? Do I add them, subtract them, divide them? One of the great guesses and one of the popular guesses is since I'm multiplying two numbers, I'm going to multiply those two exponents. So people would do equal to the 3 times 5 is 15. And that's a great guess. That's a great guess. And I hope you and everyone you know make this great guess right now and never make this guess again. Right? Because in fact, this is one of the classic exponential mistake that students make. Right. So my little mantra to you is that when in doubt, write it out. Okay, so let's see what happened when we write it out. Well, I see a heck of a lot of 2. So see, I see 2 times 2 times 2. That's the 2 to the third, right? And then another one, so times 2, another 5 of them, so 2 times 2 times 2 times 2, 4, 5 times 2. Right. So how many 2 are there? Let's see, 1, 2, 3, 4, 5, 6, 7, 8. So this is equal to 2 to the 8. And this is definitely not equal to 2 to the 15 that we make a guess above there. Right? So this is wrong. This is wrong. Okay, so how do we get 2 to the 8? Well, it's simple, right? If you take a look at this, I have 3 of the 2's here. There's like 3 of them here, and then I got 5 of the 2's here. And how do we get 8? We add them, right? 3 plus 5 is 8, so 2 to the 8. Right. So the general rules here is when you have so it's going to be equal to 2. When you multiply two numbers together, then you add the exponents. So 2 to the 3 and then plus 5, therefore is equal to 2 to the 8. Okay. Right. So the general rule is this. So here's, I list out the properties of exponents for you. Let A represent a non-zero real numbers, and M and N represents positive integers. The product properties is that if I have A to the M times A to the N is equal to A to the N plus N, right? Just like that we did here, right? We have the same base, 2 to the third times 2 to the fifth. We add the exponent together. We have 2 to the 8. N plus N, 3 plus 5, N plus N, right? So that's the product's properties. Now, what about if we have A times B to the N? So for example, if I give you, for example, I'm talking about this rule right here. So for example, if I have 3 to the 4 times 5 to the 4, well, according to this rule, is equal to what? 3 times 5 to the 4. Right? A, B, 3, 5, right? And we have the same exponents. All you have to do is bring it together and raise to the same power. Okay. And then last but not least, power properties. If I have if I have A to the M raised to the N power, then it's equal to A to the N times N. Right? Again, you can write out if you're in doubt, right? Because I don't have a lot of time to explain every single thing. So for example, if I have 3 to the fifth power and I raise to the second power. So according to this power properties, what I'm going to do, I'm going to multiply the exponents together, right? So it's going to be 3 to the 10. 5 times 2 is 10. Okay. All right, so let's see some example. Let's see some example. So according to product to power properties, what I'm going to do is I'm going to distribute the 4 into each of those terms inside the parenthesis, right? So I should have 2 to the 4, right? X cubed to the 4, and then y to the 4. So this one I'm going to write as equal 2 to the 4 times x cubed to the 4, right? Times y to the 4. Product to powers properties, right? And now we simplify. What 2 to the 4 equal to? Right, 2 times 2 times 2 times 2. So that will be 16, right? Times x cubed to the 4, x to the third raised to the 4 powers. What property is that? That's the power properties, right? So a to the m raised to the n is equal to a to the m times n. So x cubed to the 4 power, you multiply the exponents together. So I got x to the 12 times, well, y to the 4, right? Because so y right here is basically is y to the first. We don't write it out, but it's going to be understood at y to the first, right? So 1 times 4 is y to the 4, y to the 4. And that'll be your final answer. Okay, let's rewrite this. So 16x to the 12, y to the 4. All right. Okay, so let's move on to the second example. Now, if I was you for the second example, I would simplify what inside the parenthesis first before I move on to the outer exponent. So what we're going to do first is we're going to simplify what inside, right? So I have -2 times x cubed times x squared times y to the 5th. So if you take a look at here, I see x cubed and x squared. Okay. So according to the product properties, a to the m times a to the n, you multiply two same base, you add their exponents, right? So x cubed times x squared is x to the x cubed plus 2, right? So you add those two exponents together. I have what? I have x to the 5th. Right? The -2's in front here. I'll just rewrite that. Okay. What about y times y to the 5th? Same rules, right? So this is consider is y to the 1st, right? Times y to the 5th. 1 plus 5 is 6, so y to the 6th. And then all of that to the 3rd power. Okay. Now we distribute the power, right? Using product to power properties. Look at that. We distribute them, right? A times b to the n equal to a to the n times b to the n. Just distribute the power into each of those terms, right? So equal -2 to the 3rd times x to the 5th to the 3rd times y to the 6th to the 3rd. Okay, and now let's simplify furthermore. -2 to the 3rd. What does it equal to? It's going to equal to -2 times -2 times -2. Right? -2 times -2 will be -8. Right? So -8. X to the 5th raised to the 3rd. We're going to use the power properties, right? A to the m to the n equal to a to the m times n. So we're going to multiply them together. So 5 times 3 is 15. X to the 15 times y to the 6 times 3 is 18. And then we're done.